Okay, today I'm going to be talking about balancing equations. This should be a review during the second semester because you've already done it in the first semester. There are 3 rules for balancing equations. We're going to do metals or cations first, then we're going to do the nonmetals and cations next, and then hydrogen oxygen last. Now these are really more like guidelines than they are rules, but it's to help you to get through the balancing process in a logical way in which you will have success in balancing the equations. So our first example here is going to be the black example right here. So if you look, we're going to start with our cations, which is the Se. The Se is balanced on both sides, so I do not need to add anything at this time. Then I'm going to go after the chlorine. Now I have 6 chlorine here, and I have 2 chlorine here. So in order to make this go to 6 chlorine, I'm going to put a coefficient of a 3 out front. I can't change anything about the equation, but I can add coefficients out front. Now I have 6 chlorine. And now let's check our oxygen. I have 2 oxygen here, 2 oxygen here. This is balanced. Now, last thing I'm going to point out, I have somebody by themselves, somebody by themselves. We're going to call this a single replacement reaction, so I'm going to put an SR for single replacement. Some people may argue that the oxygen, since that is a compound, that acts as a double replacement, but we're going to classify as single replacement at this point. The next one up is the iron with the sulfuric acid. We have iron by itself, and we have hydrogen ends up by themselves on the other side. So this is also a single replacement reaction, just making you practicing the types of reactions. So we'll start with the Fe. So I have Fe here, it's a 1-to-1. I'm sorry, I appear to have written something down wrong, so we're going to skip that one. Let's go on to the C2H6O2. And this reaction here, this is going to be what we call a combustion reaction. Remember, at this level, organic combustion is what we're going to classify for combustion. So I'm going to start with my carbons. I have 2 carbons here. I have 1 carbon here. So we're going to drop a 2 right here. Now I'm going to look at my hydrogen count. I have 6 here. I have 2 here. We're going to put a 3 out in front of the H2. That makes 6. And then when I look, I have 3 plus 4 oxygen. That makes 7. 7 is not divisible by 2. So now what I'm going to do is I'm going to multiply everything I just did by 2. 2 times 2 is 4. Change that to a 4. Make that a 4 because 2 times 6 is 12. I'm sorry. Let's check that again. 6 times 2 is 12. Now I'm going to look at my oxygen count on this side. 6 plus 8. And then divide by 2. So that's 14 divided by 2 gives me 7. Now let's go on to this one. I'm going to start with the bromine. I have two borons here, 1 boron here. That is my cation, so I'm going to drop a 2 out front. Then let's go look at the bromine. I have 6 here. I only have 1 here, so we're going to drop a 6 out front. I have 2 ways to look at this. I can look at the nitrates as a unit. 2 times 3 is 6. So I'm going to need a 6 here. Or I can also look at my hydrogen. I have 6 hydrogen here. I need 6 hydrogen here. I'm going to drop a 6 there. Now, I'm going to double check. 2 and 2, 6 and 6, 6 and 6, and 6 nitrates, 6 nitrates. The type of reaction that this one is a double replacement.